Okay, we're just going to do a few notes here, not a lot. Just want to kind of get you in the right frame of mind what we're talking about. We're in the third section of our prerequisites. We only have a few sections left. I think we have like 2 sections left. And these go a little bit quicker, except for this one. This is the one that I'm kind of worried about from just experiencing from Algebra 2 to Pre-Calc. This is the one that you might have missed a few things here or there. The other stuff has been easy up to this point. I feel it like it's been easy, and that's a good thing. It's good to have a nice review and have a nice solid base before we get into we jump into some more challenging material. But the stuff we're going into is radicals and roots. We're going to deal with roots of some type, square roots, cube roots, fourth roots, that type of thing. And I want you to kind of know the ins and outs, the vocab terms I use. How do you do basic operations, add, subtract, multiply, divide? Do you know the basics? Today I'm just going to give you a kind of a mini crash course. I don't want to take a lot of time. I want to take maybe 10 minutes, 12 minutes, something like that, where I just kind of give you a nice little basis today, give you some time where you can work on your page 28, and then tomorrow we'll kind of come back in hot and heavy and we'll try to clean up all the missing stuff that we didn't get with this stuff. We do have it, that page 28 is due tomorrow, so keep that in mind. So that's why I'm trying to give you some time to work on it in class, so you can ask questions if you have any. But let's jump right in. Let's talk about the actual roots themselves. Let's talk about the vocab terms that are involved. All right, I'm just going to put some basic letters here. I know this seems a little weird. I'm just going to put these just for the purpose of just kind of what I want to point at. All right, this is typically some type of root for us. It's it could be any type of root, a square root, cube root, fourth root. There's a couple vocab words that I want you to know. The actual symbol itself is called a radical sign. I know a lot of people just call it a square root symbol. Man, it's called a radical sign. That's correct terminology. The number on the inside of the actual radical sign itself is called the radicand. It's the item that you are trying to simplify, evaluate. I'll walk through that, like what it's asking for here in a minute. And the number on the outside, there is a number that sits in the little tail of the radical sign. That number is called an index number. Some vocab words for you. I know some of you have probably seen that before, maybe some of you haven't. Anytime you look at some type of radical, any type, the most important number up there is not the radicand. That's the weird thing. A lot of people are like, oh, I just need to look at the number on the inside and go from there. You should actually look at what the index number on the outside is first. This number out here, whatever number they have printed, actually tells you what you should be doing. It's kind of like your instructions. It's the directions you should go. Once you understand this number, it makes this process of breaking this down or evaluating it a lot easier. So let me just kind of give you a really kind of clean, easy example. So this is my example. I'm going to stick with something simple that you just kind of know off the top of your head. Okay, so this is a square root. Now, why it is a square root? The index number on the outside in the tail, notice they don't have it printed, correct? It's not even there. There is a number, even though it's not printed, and this is the weird thing. This is the only time in math you don't assume it's a 1. In algebra, x's, variables, have 1s for a power. They have a 1 for a leading coefficient. But on radicals and roots, we actually assume it's a 2 if it's not printed. It's a 2. But again, if there's ever a 2, you don't have to actually have that written. If it's any other number other than a 2, a square root, they have to have it printed. So a cube root, a fourth root, a fifth root, they would have to have that number sit there, a 3, a 4, a 5, and so on and so forth. But a 2, you don't have to. It's assumed it's a 2. Now, does anyone actually know why it's called a square root? Anyone have kind of a clue what it's based on? Is there a root of a square? Yeah. In that terminology, you are correct. This is what this problem's based on. A lot of people you kind of explained it really, but this is actually what this problem is actually going for. This is where the problem comes from. It's the solution for the equation x squared equals 25. That's why it's actually called a square root, because this is a square. You are trying to find out what number to use square, that you put a power of 2 on, that will give you 25. That's what it's there for. So the idea of a square root and a square, they're inverse operations of each other. That's why when you take the 2 to the other side, it becomes that. It becomes the square root symbol. They're opposites. They're inverses. That's what it's used for. Now, does anyone happen to know what the square root of 25 is? 5. There's another answer. It is 5. I agree with that. Or what? Negative 5. Now let's talk about why. 5 times 5 is 25. So check. Negative 5 times negative 5 is also positive 25. There's actually 2 answers, because when you square something, the power actually tells you potentially how many solutions there are. There's 2. Square root has potentially 2 answers. It's not guaranteed. I said it's potentially 2 answers. Could have 1, could have none. It depends on what the answer is. Now, the answer I typically look for is this one, the positive answer. It is called the principal square root. Principal square root. It is the one that is pre-programmed on most calculators to be provided to you. It will not provide you with a negative number. It will provide you with a positive. So just be aware of that. There is 2 answers for some of these, and it'll just give you kind of one. It's been pre-programmed to do that. All right, questions on the terminology that I'm going to be using? Okay. Now, there is a select few set of numbers that you can actually take radicals of, like clean square roots of. And that's the list I want to go through here. This is kind of my intro day for it. So we have what we call the perfect squares. The perfect squares. The numbers that you are allowed to take a square root of that end up being a nice, clean, natural number, whole number, integer, and like nice number, right? So here's the list, and now this is in like least greatest, and there's infinite number of them. I'm just showing you the first 15 of them. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. And they just keep going over and over and over and over and over. All these numbers are perfect squares. They all have a number that's made by 2 numbers multiplied together, like the same digit multiplied together. Like for instance, one number multiplies on itself to give you 16. 4. 25 is 5. 36 is 6. I put them in numerical order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And then they keep going past that. Pretty much, these are the ones I've had to memorize in high school and college. I can get by on any number by just knowing these. I can break them down into these forms. So if these were sitting in that radical, I can give you a nice clean answer, a nice natural number, because they have nice clean numbers. Now, what happens if it's not one of these numbers? What happens if we're doing a problem and the number on the inside is not a perfect square? It's a 12. Is 12 on my list? Definitely not. So what's going to happen there? It's going to be a decimal. Not just any decimal. It's going to be an irrational number. Something that doesn't end and doesn't repeat, ever. It's a super unique number. Irrational numbers are like pi. They don't end, they don't repeat. There's an actual mathematical formula that says it wouldn't. If it definitely had a number that would repeat or end, it would be a fraction. And then that would mean it would be a nice, clean, perfect square, which it's not. So there's a whole complicated proof of why it won't end up being a nice clean number, but that's right, it's a decimal. Now, can anyone without a calculator now predict what that answer would be? Ballpark it.
3.5.
Okay, I'll go with that. Why? Let's say it's that. I don't know for sure, but why?
Because 3 times 3 is 9.
Okay.
And 4 times 4 is 16.
So it's in between there, right?
Yeah.
It's between 9 and 16. It fell in here in my list. The answer for 9 would be 3, like you said, and the answer for 16 would be 4, and I like the logic. It's somewhere in between. And that's exactly how you estimate radicals. You figure out, okay, where does it sit between? And that's the decimal roughly where it's gonna be. You know, for me, 12 is closer to 9. It's closer to 9 than 16, right? So it's closer to 3 than it is to 4. So I don't think it's gonna be 3.5. I think it's gonna be 3.4 or somewhere closer, because it's closer to 9. So it's not gonna be in the perfect middle, it'll be closer to 3. That's how I estimate it in my head. Now, did anyone have a calculator that knew how to type it in? Please. Because I don't know, honestly.
3.464.
Okay. Close though. I mean, if you rounded yours, 3.5 is a really good guess, like solid guess. That's exactly how I do it. So if I was ever on like an ACT or some type of standardized test, and they're asking me for radicals, I just ballpark it. Like, it's about 3.5. And then that's the number I use to do the rest of the calculation. And then I try to figure out which one, A, B, C, or D on my little standardized test, which one falls in that range, which one's better. And I don't even have to solve the entire problem. I can just do it really fast, estimation. That's the quick way to do standardized tests. Try to figure out the shortcuts without actually doing all the real math. Eliminate the answers that don't make sense.
What did you get on your ACT?
I have no idea. Honestly, don't. Yeah, now I was able to only 7 here. So, all right. Now, is there any questions with that idea? Okay, now what we're going to learn tomorrow, what we're going to really practice is like, instead of giving me decimals, like irrational numbers, like an approximation, I want exact answers. That's called simplest radical form. Can we break it down into the exact answer without decimals, without typing in a calculator and figuring out what that form would be? That's what we're going to look at tomorrow. Does that make sense? Now that's a tall order, right? We still have to talk about adding, subtracting these things together, radicals, multiplying and dividing them. So we have quite a bit of notes to take tomorrow. But this is just, I wanted to intro this for you today. If you have a calculator, be a smart idea to bring it, because it's nice to kind of check to know that you know how to type it and what buttons to hit. So that's what we're going to look at tomorrow as well. Okay, we're done for the day. I did promise you I want to get done, give you about 10, 15 minutes to kind of work. You have almost 20. You can work on your assignment. Now, if you get done with your page 28, you can turn it in. You guys know the drill. Front basket, back basket. Turn it right to me, I don't care. It's due tomorrow. Okay? All right.